Hey, Algebra 2, let's do Lesson 3. Lesson 3 reminds me of when I used to hang out with Paul George a lot. Those were the good old days. He used to ask me, like, hey, what do we need to know in order to be able to write the equation of a parabola that has a vertex at the origin? So I would draw this for him, like every time. So if it's opening up or down, see, what would we need to know to be able to write the equation? It looks like we would just need to know what P is, right? Because it's gonna, wow, that was awesome. Do over. Looks like we would just need to know what P is, right? And then we have our equation. Y equals 1 over 4 times P x squared. So all we really need to be able to do is figure out what P is and then use one of these two forms. So let's try this, shall we? Alright, so this one is opening down. So this is going to be a y equals 1 over 4p x squared kind of a deal. And we need to figure out what p is. Well, if you recall, p tells you how far away the directrix and the focus are, right? P, in this case, is going to be -3 because your focus would be right here. Your directrix would be 1, 2, 3 up here. So your directrix is y equals 3. Your focus is 0, -3. So P equals -3. And so remember, if it's opening down, your P has to be negative, because that will make your A negative. If that makes any sense to you. If you know what those letters are that we've been talking about so much. Alright, so I'm going to plug my -3 in for P. Y equals 1 over 4 times -3 x squared. And so this is y equals, we got a positive 1 on top, we'll have a -12 on bottom. Positive divided by negative is -1/12 x squared. Ding! That wasn't so bad, was it? Let's take a look at this guy. We need to identify the focus, directrix, and axis of symmetry of this here parabola. Well, let's see now. Let's remember some information. This is a y equals something x squared, so y equals 1 over 4p x squared. That means that 1 over 4p is the same thing as 0.5. And now we can use our mad algebra skills to figure out what p is, because 0.5 is the same thing as 1 over 4p. I'm going to multiply both sides by p. Then I get 0.5p equals, and then these p's cancel, 1/4. And now to get p by itself, you can think of it as dividing both sides by 0.5, or if you multiply both sides by 2, what's 2 times 0.5? It's 1. So I am going to multiply both sides by 2 because that looks easier than doing a fraction divided by 0.5. So that gives me 2 times 0.5 is 1. P equals 1/4 times 2 is 2/4, which is 1/2. So P is 1/2, also known as 0.5. Those are the same number. All right, so I need to find my focus, directrix, and axis of symmetry now. So now this is not always the case, and this is a very rare situation where your A is the same as your P, because 1/2 is the same as 1 over 4 times 1/2. It's like the only number that does that. So don't go thinking that this is P every time. It's not. This is not P. Okay, anyway. This is 1 over 4p, remember? All right, so we found out that p was 0.5. Our focus is 0p. So our focus is 0, 0.5, also known as 0, 1/2. Our directrix is y equals negative p. Y equals negative 1/2. And our axis of symmetry goes through the focus, remember, and it is perpendicular to the directrix, so it's our vertical line, it's our y-axis, and the equation of the y-axis is x equals 0. All right, now let's graph it. So the vertex is at 0, 0. The focus is at 0, 1/2. Well, I don't want to draw that like 0, 1/2 is right here. So I'm going to label my axes so that 2 blocks is 1. So 0, 1/2 is over 0, up 1/2, it's right there. The directrix is y equals negative 1/2, so that's going to be the horizontal line going through negative 1/2. And now I will pick some x values to plug into our equation to figure out the y values, so I got some points. So let's pick 1. So when x is 1, y equals 0.5 times 1 squared, which is 0.5. And when x is 2, we do y equals 0.5 times 2 squared, which is 0.5 times 4, and 0.5 times 4 is 2. So here's a point, 1, 0.5. Over 1, up 0.5. And 2, 2. So over 2, up 2. And remember, my axis of symmetry goes through the focus perpendicular to the directrix. So my axis of symmetry tells me that I have a mirror image of each one of these points straight across. So this one would be negative 1, 0.5, and negative 2, 2. And then I just draw a nice pretty curve going through those points the best I can. Ding! Alright, so here is a couple of problems where we know we got a parabola with a vertex at the origin, and they're going to give us either a directrix or a focus, and we got to figure out the equation of that parabola. So here we got the focus is negative 3, 0. So if we want to visualize what that's going to look like on a graph, 1, 2, 3, there's negative 3, 0, there's our focus. That means remember our vertex was at the origin, so our directrix is going to be 1, 2, 3 over here. But our p-value is negative 3. Because this guy is going to be opening to the left, open towards your focus. And this is going to be x equals 1 over 4p y squared. P is negative 3, so x equals 1 over 4 times negative 3 y squared, and that's negative 1/12 y squared. If the directrix is x equals negative 2, so x equals negative 2 over here, so all the points that have an x value of negative 2 are in this vertical line. All right, and that means that our vertex is at the origin and our focus is over here at 2, 0, So we got a parabola opening to the right, and P is 2. So this is opening to the right, so it's going to be an x equals y squared kind of a deal. X equals 1 over 4p y squared. P is 2. So 1 over 4 times 2 y squared. So x equals 1/8 y squared. That's the end of this one. Hey, listen, Algebra 2 student, you are awesome. Please stay that way.